Alright, this is Notes 10-1. This is a new unit. We're starting to work with square roots. We're going to start with the graphs. When we work with this, I want you to think about the fact that we've talked about vertex form of a parabola, of a quadratic equation, because quadratics are parabolas. The vertex form is y equals a x minus h squared plus k. Remember, A is the stretch compress. Okay, so if A is, the absolute value of A is greater than 1, it's a stretch. If the absolute value is in between 0 and 1, then it's a compress. A negative A means it's reflected. It's over the x-axis, and then the vertex is at h, k. This is your vertex. So the h controls the left, right. If h is going to be a positive h, in other words, if you see x minus h in the equation, then it goes to the left, to the right. If there's a negative h, meaning you see this in the equation, you're going to go to the left. And the k, of course, positive k is up, negative k is down. So we're going to do a similar thing with radical equations. But first you need to know what a square root function is. It's just a function that contains a square root with the independent variable under the square root, so the x. These are all square root functions because they have the x underneath. These are not square root functions. This is just a constant. This one has the x outside the radical, and this one has an x added to the radical. Those are not square root functions. The parent function of a square root is f of x equals the square root of x. It's important to understand these parent points. Now I'm going to make a table of values for this using 0, 1, 4, and 9 as my x. Can you figure out why I do that? It's really because the square root of 0 is just 0, the square root of 1 is 1. So these are perfect square root numbers. So the square root of 9 equals 3. So if I want to figure out a points table for this, y would be 0 because the square root of 0 equals 0. Square root of 1 equals 1. Square root of 4 again is 2. Square root of 9 is 3. So the coordinate points I can use to graph this, because I plugged in my x values into the equation, are 0, 0, 1, 1, 4, 2, and 9, 3. So if you look at the graph of this after I plot those points and then connect the dots, this is what it looks like. And we always put an arrow at the end. Let me fix that here. That was 9, 3. So this will continue on forever and ever. It goes that way. But it starts at that point 0, 0. And then the y, it also keeps going up forever. It doesn't go up forever very quickly, but it goes up forever. This kind of looks like our half parabola, right? Half of a parabola, but it's on its side. The domain of this is all x's such that x, now it doesn't go to the left, it just starts at 0, 0, but everything goes to the right, so that's x is greater than or equal to 0. The range of this is all the y values such that y is greater than 0 as well. So it starts right here at 0, 0, and then it goes up. On your calculator, I want you to graph the function, the parent function, y equals the square root of x in a y1. To get to the square root, you're going to do second x squared, and then put in your x, and then we graph it. And my window is not a standard window, so you want to start with a standard window on Zoom 6. So there's the parent function. Parent functions, again, are just the variable with whatever exponent or root or whatever is working with it. Anyway, so this is a parent function. Parent functions usually just have a variable. This is the parent function of a line. This is the parent function of a parabola. This is a parent function of a cube. This is a parent function of a square root. Okay, so next thing we're going to do is we're going to graph y equals 3 square root of x and y2, and y equals 1/2 square root of x, and see what the difference is with those. So this is the way that you should put your equations into your calculator, and then we press graph. And remember the 3 square root of x is the red one, the 1/2 square root of x. Oh, I did that wrong. This one, do you see what's wrong with my thing? I need to put my square root of x over here. So you need to put the arrow over. So second square root and then x. Okay, now it's set up. So now we're going to graph it. Okay, so see the 3 stretched it, and it made it taller, and the 1/2 made it smaller. So when we're looking at this, let me trace. All right, there's my sketches of my graphs. This doesn't go down, it just continues going up. So as you can see, the 3 square root of x is stretched, the other one is compressed. The domain and range on this, though, they always start here. Okay, this is always our start. Notice that they didn't translate left or right or up or down. Just like when we do a parabola, we look at the vertex for its transformation. There is no transformation on any of these for left, right. They're just stretched or compressed. So we could say the number in front is the one that does the stretch and compress. You're going to see this is called A in just a minute. So the domain on this, it goes from x and it goes to infinity, or 0. Thinking of my algebra 1, algebra 2 stuff. All right, so it's all the x is greater than or equal to 0. The range of this, same thing as before, y, such that y is greater than or equal to 0. And then on the next one, same thing, x such that x is greater than or equal to 0. The range is y such that y is greater than or equal to 0, just like before. So the transformation, when I have an A in front, the transformation of this is the effect is to stretch and compress. So you can try this one and see how it compares. Oh, this one, we actually kind of need to look at this, because the only difference between this one is that there's a negative right here. So this first one, y equals the square root of x, we can look at this as being y equal 1 square root of x. That's your A value in front. The other one, square root of x, negative square root of x, is the same thing as y equals negative 1 square root of x. So if we graph these on the calculator, you're going to see there's a mirror image of this one over the x-axis. So this is reflected over the x-axis. The domain and range on this, same thing as always, because we haven't translated this any. X is greater than or equal to 0. The range of this is y such that y is greater than or equal to 0 again. So you're going to see eventually that this is y equals a times the square root of x minus h plus k is the standard form of this. So we're just looking at the transformation of A so far, and that's the stretch and compress. It's just like we've talked about before. If A is positive, this one goes up. If A is negative, this one goes down. And then the starting point of this, the start, is also at HK, just like we had, let me fix that to be a H. When we talked about vertex, the vertex was a H and K, and this is the thing we looked at for our left, right, up, down transformations. This time we look at the starting point of the quadratic, of the root graph to be our transformation point. So we'll explore this in a minute. later. Okay, but just know that A up, positive, goes up. A is negative, goes down from left to right. And then if A, the absolute value of it, is greater than or equal, or greater than 1, not equal to, then this is stretched. And then if the absolute value of A is in between 0 and 1, then this is compressed. It's shorter. Next, we're going to look at what happens with the K. So here's the K value. We're going to compare these, so I want you to go and compare these on your graph, on your calculator. Did you notice that the parent function, instead of being with y equals x plus 3, it shifted up to 1, 2, 3. It shifted up here, but the graph looks pretty much the same. So this is going to be y equals the square root of x plus 3. If you haven't done this on a calculator, I suggest you do. And make sure you watch out for this plus sign. You have to arrow over out of the square root sign to get that just a plus by itself. The plus should not be underneath the square root sign. And then if I do the same thing with this one goes down 5. So that other one went up 3. This one, 1, 2, 3, 4, 5. So this one, same thing, but the shape of this didn't change at all. It just went down 5. So the effect of the K is the K is positive, it transforms up. If K is negative, then it transforms down. And where you're looking for is the starting point again of the square root function. The domain of the one that has the plus 3 is still all x's such that x is greater than or equal to 0. The range of this, though, is now all y's such that it starts at 3. So y is greater than or equal to 3. So the domain of this is x is greater than or equal to the h, you're going to find out, and y is greater than or equal to k. So we're going to do the same thing with this one. X such that x is greater than or equal to, what do you think it's going to be? Negative 5. 0, sorry. The range is y such that y is greater than or equal to negative 5. So we're messing with the k right now. All right, go to your calculator, and I want you to put these functions in. Do this again, and look and see if you can figure out what the h does. So the h is underneath the square root sign, though. So pause the video and try this and compare it. So when you graph this, you should have seen a shift to the left and to the right. The domain and range of this now, the y value, this should be x, and this should be y. Okay, the y value has not gone up or down, so these are still y is greater than or equal to 0. And that's because, remember I told you about the k and how this is y is greater than or equal to k? Well, k in this case, since there's not one, it's 0. The range of this, though, is shifted. So this one is all the x's that are greater than or equal to for both of these. It always turns out to be greater than or equal to. But this is x is greater than or equal to negative 5. X is greater than or equal to 2. So the h in this case, h equals 2. H equals negative 5. Remember, this is opposite because we always put x minus h in there. So if h equals negative 5, then the square root of x minus h is going to be x minus negative 5, which is x plus 5. So now here's a full transformation one that we're going to play with. We want to see how this differs. So a, again, is stretch and compressed. So a equals negative 3. H equals negative 1. K equals negative 3. So this one is reflected. H is negative 1, means it goes to the left 1. And we always drag this initial point here. So this is to the left 1. And then K negative 3 means it goes down 3. So the graph of this will look like this. Don't forget, when you're putting this in the calculator, you have to use your arrow at this point right here to make sure that -3 is not underneath the radical sign. The domain and range of this function then is all x's such that x is greater than or equal to the h. And then the range is y such that y is, now this one is a little trickier because it's upside down, it's going down, y is less than or equal to, and here's the max point right there, that's y equals -3. So the ones that go down, you got to be careful. In fact, let's go back up here to the reflection one, because I did not do this one right. So the domain and range on this one is all the y's such that y is less than or equal to 0. So when it goes down, its y is less than or equal to. When a graph goes up, its y is greater than or equal to. All right, now we're going to learn how to do these transformations with this formula. This is kind of the summary of everything that we've already talked about. So here is what we do. This process involves knowing a, h, and k from your graph. So we're going to identify this as 1/2. H is 0 because there's nothing underneath the radical with the h, with the x, and then k is -4. The parent points we got from the very beginning of this, so you need to know these parent points, 0, 0, 1, 1, 4, 2, and 9, 3. We just took the square root of the x values to put those in. Okay, so let's go back here. We're going to use this process that you're going to use all the way through Algebra 2 and Pre-Cal and just forever, and set up a points table for the transformation. The first column is going to be x plus h. If you notice, our h is 0, so this x plus h is just x plus 0. So my x values over here, because that's what we're adding, I'm just going to add 0 to those so they turn out to be the same. So this is going to be 0, 1, 4, and 9. So I just put x right there. ay plus k means I take the a value, I'm going to multiply the y value from the other column, and I'm going to add k to it, which is -4. So 1/2 y plus -4 is just 1/2 y minus 4. So this is a process we're going to do. So in my y column, I have y equals 0. So if I'm going to do 1/2 the a, y minus 4, I'm going to take that y value and I'm going to put it where the y is. So that would equal -4. So from this, I know that -4 is one of the points on our translated graph. So I'm going to plot the point 0, -4. And that makes sense, right? Because it translated down 4. So then I'm going to take y equals 1 and do the same thing. 1/2 times 1 minus 4. So that's going to be -3 and 1/2, because I'm 1/2 more than -4. So I'm going to put that here. So my next point is at 1, -3 and 1/2. So I'll go over to 1 and down to -3 and 1/2 and put my next dot. Then I'm going to do the same thing with the 2. So again, we're working with these columns to put them into the y value right there. Okay, so this is going to be 2 is what I'm working with. So I want 1/2 of 2 minus 4, so that's just -3. So my next point is at 4, -3. So I go over to 4 and down to 3. Do you see the shape starting? So now we're going to do the same thing with 3, because that's the next, the y value is 3. So 1/2 times the y value of 3 minus 4 equals, so let's do a little bit of fraction math, shall we? 3/2 minus 8/2 will equal just 5/2. So this equals 2 1/2. And it's a negative. So we're going to make this negative. So this is negative 2 1/2. So my next coordinate point is at 9, negative 2 1/2. So I'll go over to 9 and then down to 2 1/2. So this one isn't as steep as the parent function would be. If I were to graph the parent function will look like this. It's at 0, 0, 1, 1, 4, 2, and then 9, 3. See how this one, the parent, is more steep, more stretched than the other one, which is y equals 1/2 square root of x minus 4. And this process will work for any of these kind of square root functions. It works with more complex ones as well. The domain of our new function is all the x's such that x is greater than or equal to 0. And then all the y's such that y is greater than or less than. Well, here's our 0 point, and all of our points are going up. So y is greater than or equal to our minimum of negative 4. Okay, so this next one, I want you to try it and pause the video, make sure you can do it. All right, how did you do? Did you see that your x values of your parent points? We're going to add the h value to this, which is 5, so now we're subtracting. So the x values go here. The y values end up going in the ay plus k. And you get your coordinate points. And this makes sense because this plus 2 means it's going to go up 2. This x plus 5 means we're going to go to the left 5, which that's what happened to our starting point. The 1 means it's not reflected, it's just transformed. It's not even stretched. And then I put these in parentheses. These are just to remind you where the domain and range come from. All right, the word problem. This one is just as simple as identifying where everything goes. So the speed s, so speed is s, of a tsunami in meters per second is given by the function where d is the depth of the ocean in meters. So d is the depth of the ocean in meters. So if a tsunami is traveling in water 26 meters deep, so that's going to be our d. What is its speed? So speed equals 3.1 times the square root of 26. Go to the calculator. We put in 3.1 times the square root of 6, and we end up with speed equals 7.6, and the units is meters per second. So we write it like this. And then one more check. This is without graphing. Make sure you understand that the domain is x is greater than or equal to the h. Y is either y is greater than or equal to k, or y is less than or equal to k. Okay, and this happens to do with whether it's facing up or whether it's facing down. This one has a positive a, so it's facing up. So the domain of this is all the x's such that x is greater than or equal to, now h is negative 4. Negative 4. And then the range is all the y values such that y is going to be greater than or equal to the k value, which is negative 1. So you should be able to pick that out of the equation. And that's it. Have a good day.